Hey everybody, Mrs. Bianchi here. We're going to be playing a game called Over the River. So before we talk about the game strategy, let's think about what we know about dice. We're going to be throwing a pair of dice, and when we roll the dice, in this example, we just rolled 7, so I'm just going to write that number down. Roll a 7, we'll roll again. That time we rolled an 8, and that time we rolled a 10. All right, so we're just going to use those first 3 rolls as an example on how this game works. Let me minimize this. All right, so here's the game board. Now, another thing I should mention is we're going to keep track of the numbers that come up. So in the experiment that we just did, we're going to make a dot plot. So the number 7 came up, the number 8 came up, and the number 10 came up. And we're going to keep track every time a number comes up. Now, on your game board, you will have some time to think about where to place your markers because this game is called Over the River. Now you're going to place your markers on this side. You have to decide where to place them. We have numbers 1 through 14. And if the sum comes up, so for example, let's say 7 did come up and so did 8. Now see how I have a marker on the 8? Since 8 came up, at the time that it came up, I would go ahead and cross that over the river. Now 10 came up and so did 7, but I don't have any markers on that. So I wouldn't be able to cross them over the river. So let's roll the cube again, and let's see if the way I have my game board set up, I'm going to roll the dice, and that time we have 5. So if we look at my game board, is 5 on there? It is. So I would get to cross the penny over the river. Now if you're playing this with a bunch of classmates, the first of you that crosses all of your pennies over the river will be the winner. Now, when we typically play this in the classroom, we usually play a minimum of 3 or 4 games, and then we analyze the data that we have. So let's go back and look at the data that we had so far, right? We had a 7, we had an 8, we had a 10, and I forget what we rolled last. But each time we keep track. Organizing your data this way in a dot plot can really help you understand some things about collecting data. Now, once we played this game a few times and we continue to collect our data, some of you are going to notice something and you might change your strategy. Now, if you're a student playing this game for the first time, it's my recommendation to generate a good strategy is you want to think about all the possible ways that you can get certain numbers. So for example, in this last roll, we rolled a 5, and one way to get 5 is by 1 plus 4. But is there another way to get 5? For example, 2 plus 3? Is that possible to get that on the number cube? So if you make an organized list of the different ways that you can get the sums, it might help you to see that there might even be some values on this game board that have what we call a 0 probability. So a 0 probability means it'll never happen. It's impossible. And if you put your marker on something that's impossible, then you'll never win the game because you won't be able to cross all of your markers over the river. All right, so if you're a teacher using this or a student, you're going to hit the pause button. And then we'll go ahead and play the game in class. And in just a moment, we're going to continue and talk about some data displays that we've collected from other groups. All right, so hit pause, and then we'll hit play again. All right, so what we're going to look at next is we're going to look at some actual data displays that were collected. So this is the one, let's see if I still have this one, not this one. Let me go to the next slide. This was a data display that we collected, I think, in the year 2020. And what we notice here is we played 4 games. So the red game was the first game, and then the blue game, the green game, and then we went back to blue. And what you're going to see here is the mode in this game was the number 7 and the number 10. We had 2 modes. They occurred most often, and 3 also occurred a lot too as well. So when this was going on, students started to place their markers on the 3, the 7, and the 10. And they weren't really thinking about the actual theoretical probability. A lot of people fell for going for that 3. Let's look at data from another year. So this was the year before, and I wrote down all of our winners from that year. But the mode for this particular game, 6 and 7 occurred the most often. So we ended up having 2 modes. And also another one that came up quite a bit was the number 10. Let's look at another data display. This was a shorter game, but you can see that the mode here was 6 and 7. And this was back on May of 2017. And here's another group. The mode on this one was 6. That was another one that was done May of 2017. Now, what do we learn from this? Well, one of the things that people always say to me, oh, I wish I had thought of that. Now, you should really think about how many outcomes there are altogether on the number cube. And one thing that's probably a good idea is visualize one of the cubes as being one color. So in this example, we have a red and a white cube. Now, if this is one outcome right here, and we count how many total outcomes we have, so that's 1, 2, 3, 4, 5, 6 going that way, and 1, 2, 3, 4, 5, 6 going that way. So we really have a total of 36 outcomes. And one of the things that you should notice is the highest sum that you can roll is a 12. If you put your marker on the 13 or the 14, those are zero probability outcomes, and therefore you would never win the game. Now, likewise, if you put a marker on the 1, the lowest number you can get is a 2. You can't get a 1, so that's another example of something that has a zero probability of occurring, and if you put a marker there, you would never win. Now, what's nice about this data display right here is it shows the actual sum rather than just the number cubes. And your first cube could be a 1, a 2, a 3, a 4, a 5, or a 6. So let's say that first cube was the red one. And the second cube could also be a 1, a 2, a 3, a 4, a 5, or a 6. Now, when you look at the sum, 1 plus 1 would give you 2. So that's representing numerically what you see here in this image right here. Now, if we look at how many total outcomes, remember there's 36 outcomes. What's the one that occurs most often? If you look right here and count how many ways you can get 7, it's 1, 2, 3, 4, 5, 6 ways that you can get a 7. So the probability of rolling a 7 is 6 out of 36, and of course we can simplify that to be 1/6. Now, if you look at the actual displays of the dice, on the red you could roll a 6 on the red, and on the white you could roll a 1, a 5 on the red, a 2 on the white, a 4 or a 3 or a 4 if we reverse the color. And then this is kind of the opposite of this, right? The red and the white cube, and then the red and the white reversed from the other one. So that's this many outcomes. That's the most probable. Now, next in line is the most probable, would either be rolling an 8 or rolling a 6. We have 1, 2, 3, 4, 5 ways to roll an 8 or a 6. So the probability of rolling an 8 is 5 out of 36, and the probability of rolling 6 is also 5 out of 36. All right, and then if you look at the ways to roll a 6, so this is showing rolling a 6, this is showing rolling a 6, that's a 6, this is a 6, this is a 6, and rolling an 8, we can roll an 8 by doing that, 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 or that. All right, next, rolling a 9, 4 ways to roll a 9, and there's also 4 ways to roll a 5. So the probability of getting a 9 is 4 out of 36, and the probability of rolling a 5 is also the same thing, 4 out of 36. And of course we can simplify that, but we're going to leave it unsimplified because that's going to help us to understand things a little bit better. All right, next in line for being the next most probable would be the 10 and the 4. If you look at all the ways you can roll a 10. So here's a 10 right here. 10, 10, right? There's just 3 ways to roll a 10. And likewise to roll a 4. You can roll a 4, roll a 4, roll a 4. So probability of rolling a 10 or probability of rolling a 4 is 3 out of 36. Both of them are 3 out of 36. And again, we can simplify that, but we're going to leave it unreduced. All right, the next on here would be rolling an 11 or a 3. Rolling an 11 or a 3. If we look at ways to roll an 11, so we can roll an 11 that way or this way. And rolling a 3, we can roll it this way or this way. So that's 2 out of 36. Probability of 11 equals 2 out of 36 unsimplified, and the probability of rolling a 3 also 2 out of 6. I'm sorry, 36. 2 out of 36. All right, and the last most probable thing would be to roll either a 12, which we can see we can do it that way, or a 2, which we can roll it that way. So probability of a 12 is just 1 out of 36, and the probability of rolling a 2 is 1 out of 36. And of course, if we had to talk about other things like probability of rolling a 13 or something like that, that's 0. 0 out of 36, so that's impossible. All right, so the closer a number is to 1, 1 would mean that it's absolutely going to happen. If we had 36 out of 36, so let's say we're talking about the probability of getting a number that's less than 12 or less than 13. That would be 100%, right? Because all the sums would end up being a lower number than that. That would be 100% or 36 out of 36. So I think making organized lists and organizing tables can really help you to understand probabilities. So let's go back to the strategy that people would probably use now, knowing what we know. Now, it would be foolish to put your marker on the 1. It would be foolish to put your marker on a 13 or 14 because those have a 0 probability. Now, one of the things you can do in the game is you can stack your markers. So, for example, if you thought that 7 was a good strategy, to put many of your markers on the 7 and maybe put a couple on the 6 because they're also pretty probable, and a couple on the 8, this would probably be a good strategy to implement. Because you don't want to stack. Why is stacking all of them on the 7? Why is there an argument that that might not be the best idea? And it's because you might miss out on the opportunity because 6 and 8 are going to come up a lot. You don't want to miss the opportunity to cross your pennies if a 6 or an 8 come up and be stuck. But 7 is the most probable, but I do like the strategy of spread loading it just a little bit. All right, so hopefully you found this video helpful and fascinating. It is always kind of fun to see people develop strategies at the beginning of the game, because usually we find that as a teacher, we find that, and I've done this activity for years, by the way, most 6th graders are not really aware that there are numbers that have a higher probability, so they just kind of spread all their markers on the board without any thought. And then as we use the data display really does help people make better choices as we're playing the game. All right, so again, what is this called? It's called Over the River, and what data display did we create? It's called a dot plot.